Let us now discuss the activity that you did where you graphed or you plotted distance versus time graph if you have a constant velocity. Now, I hope you did your graph. Now, you can compare. I will not have the same values that you have in your activity, but at least you can verify whether you did the right thing or not. So, here we will talk about the graph of distance traveled, distance covered or traveled versus the time interval or elapsed time. So you could talk about elapsed time, time interval, duration of time. They all mean the same thing. And so now we'll have a graph of distance versus time. You had this in your activity. Suppose you were given the time at t equal to 0. You have an object or a car, a jeepney, a tricycle, which starts from rest, and we say that the initial distance will be, distance covered will be 0. Now, our unit that we will use, just so it will be familiar to you, let's say this would be in kilometers, and your time, we use the symbol, okay, so 0. We start everything from 0, and let me just, because in your activity, you have your table of values. Okay, now, so suppose after 1 hour, then your jeepney or your tricycle has traveled 10 kilometers. And then after 2 hours, you have 20. And after 3 hours, you now have 30 kilometers traveled, and so on. So say at 4, you will have 40. Then you were asked to plot a graph of distance versus time. So this is your vertical axis, because it's distance versus time. And you have your horizontal axis. So this is now your time. And we have to specify the unit. So for distance, we have kilometer. And for time, we use the unit here, which is the hour. And let's mark off our intervals. Say you have, so roughly you have, so on. So on your graphing sheet, of course, you have better intervals there in your activity. But let me just give you a rough estimate here. Okay. So we start from 0. That is your origin, and then this would be 1, 2, 3, 4, 5, and 6, and so on. And here, let's use bigger intervals because of the values that we have. Then you have 10, 20, 30, 40, and so on. So your graph extends. And then we plot the values. So, for example, let's pick 0. And you have, of course, it's 0. So this is just your point. Now, at t equal to 1, your distance is 10. Here. At t equals 2 hours now, then it is 20. So, on your graphing paper, of course, you have all the lines. So, your graph will be more accurate than mine. And then at t equals 3, you have 30. 30 is here, and 3 is the point here. And 4 would be 40. So, 4, and you have, so it should be roughly here, 40. And then, of course, you might have connected the curve or the line. And as you see, you get this graph of your distance versus time. Now, then you can talk about the slope. So here, this is a good chance for you to review your second-year algebra. Suppose I ask you now to find the slope of the line. Now, you know that for the slope of the line, you simply take two values. So you may look at this interval, for example. This interval. And let me call this my point 2 and this as my point 1. Then, remember from your algebra that the slope of the line is just equal to what you remember, the rise over the run. That means the rise is this and the run would be this. And so if we assign for P2, the distance would be D2, and for P1, it would be D1, and so on also for T, and so on, then this would simply be, let's look at the value there, say D at point 2 minus D at point 1, and now you divide it by this interval. This is now the run, if you remember your second-year algebra. So this would be the T at point 2 minus the T at point 1. And now you just substitute the values. This would be 30, and the unit, of course, kilometers, minus what is the D at point P1? That would be 20. So you have 20 kilometers. And now you divide the time at P2. This is the time value now. It is at 3 hours minus the time at this point. So again, you just check the value that you have, and you have 2 hours. And then the rest is just your arithmetic. 30 minus 20 is 10 kilometers. 3 minus 2 would be just 1 hour. And so you find that the slope is just 10 kilometers per hour. This is the slope. And now you might notice, because of the unit, it is kilometer per hour. If you remember the way we define velocity or the speed, you can now identify the slope as the speed of the constant speed of the object that is traveling. Why did I say constant? You can do this now. I will not do this here for you, but you can do this during your activity time. You can check that for a line, whatever 2 points that you take, you will always get the same value of the slope. You will always get, suppose you choose this point and this point, find the rise over the run, you will find, you can do this, check the value of the slope, and so on. And therefore, you see now that you have, for the distance, versus time graph, the slope is just the speed. The slope gives the speed. Now this is the simplest case. As you see, it is just a straight line. Since the graph is a straight line, then the slope, as you will see, is a constant. Straight line, the slope is constant. Okay, now this is important, and I hope you remember. You can even connect now this lesson for the distance versus time to your second year mathematics, where you have the slope of the line as, or the equation of the line. I will just put it here. So recall, for a straight line graph, you had your equation y equals mx plus b. Now let's look at this. In this case, your y is just your distance, and your x corresponds to your time. And so you will have and then the slope will be the velocity. Although for this graph, what would be the y-intercept? The b here, which is your y-intercept, as you notice, it is the point where the line crosses the y-axis. It's just 0. So in this case, your distance is equal to v times t. This is the slope. This now corresponds to your y equals mx plus 0 intercept. So this is what you learned in your algebra class. As you see in physics, we simply have the correspondence now for the distance versus time. So I hope you will now do the next activities, because once you go to the other kinematic equations for distance versus time, but where velocity is not constant, you will not get a straight line anymore. You will get a far more interesting curve, especially when you work with distance as a function of time for free fall or for an object moving with constant acceleration.